Hello everyone, welcome again to ITEP 203, Quantitative Methods including Modeling and Simulation. We're still in our third lesson, which is entitled Probability and Linear Programming. For this week, we are going to discuss about linear programming, the second part of our lesson 3. For session overview, you had your Module 3, Self-Study and Engagement Activity 3.2. On day 2, synchronous class for Module 3, Part 2, which is about linear programming. And day 3, you have to answer the task performance 3.2. The objectives of this lesson is for you to be able to learn the concept of linear programming or LP, learn when to use linear programming, and learn how to analyze and solve LP problems and apply graphical solution to the problem. So what are the content of this discussion? First, we need to know ano ba yung linear programming? And then, example of a linear programming problem and formulating a problem, the common terminologies used in linear programming, and solving linear programs by graphical method. So first, let's discuss ano nga ba yung linear programming? So let us watch this video. Introduction to Linear Programming by Don't Memorize.
We all come across many target-based situations in our day-to-day life. Can you think of any? Say, a student has to complete a project in 15 days, or a salesperson has to achieve a sales target within a month. Another person has to buy an electronic gadget within a budget of $500. Go through these situations and try to find out the main object to be achieved by each person individually. What is the objective of the student in this case? Yes, she wants to achieve the maximum score in this project. Can you tell me the objective of a salesperson in this case? Yes, he would aim to achieve maximum possible sales in a month. What do you think would be the objective of the person buying a gadget? She would try to minimize the cost as much as possible. She'd buy a gadget that falls within her budget. We can see that in each of the cases above, the objective of the situation was to maximize the benefits or minimize the cost. Such types of problems are called as optimization problems in mathematics. Thus, an optimization problem may involve finding maximum profit, minimum cost, or maybe minimum use of resources. There can be many more examples from our day-to-day life which need to be solved using the optimization technique. The problems can be as simple as stated above, but could get complex depending on the situation. We have already discussed about the objectives of the three given situations. Now we will look at the other important factors. We will identify the limiting factors in each case. What does that mean? Well, in each case, there is a scarcity of some resource. Like in the first case, the time limit to complete the project is limited. Time to be allotted for completing the project is limited to 15 days only. Likewise, in this case too, time is the limiting factor. The salesperson has to sell the maximum possible products in a period of 1 month. What can you say about the third situation? What's the limiting factor in this case? The person has to buy the gadget within a pre-decided budget. That means the amount to be spent or money is the limiting factor in this case. These limiting factors, that is the scarce resources, act as constraints in finding the best possible solution of the given problem. In simple words, the aim of the optimization problem is to find the optimum solution subject to constraints of the given problem. This means we need to find the best possible outcome by allocating the scarce resources. But how are these optimization problems solved in mathematics? There are different problem-solving techniques to solve such problems. They come from a very important area of mathematics called as optimization techniques. Yes, there are many different categories of the optimization techniques. Some of them can be seen here. One such technique that we will discuss in our upcoming lessons is linear programming. What is linear programming? How is it used to solve the optimization problems? Let's find the answers to these questions in our next lesson.
Okay, you saw discussion about linear programming. So let's define linear programming further. When you say linear programming, ito ay mathematical concept na kung saan ay ginagamit para magbigay ng solution sa isang linear problem. Typically, ang goal ng linear programming ay i-maximize or i-minimize ang specified na objectives. Halimbawa ay ang profit or yung cost. Ang process na ito ay tinatawag na optimization, na kung saan ang kinakailangan mong alamin na concepts or na information ay yung variables, objectives, and constraints. Ano ba yung variables? Ang variables ay yung quantity ng product na kailangan i-produce. Ito ay isang halimbawa. These are numerical or Boolean values. So, sa linear programming, kailangan i-determine yung optimal value for such variables. So, first, we need to define these variables. And then, ang linear programming yung magde-determine kung ano yung optimal value para dun sa mga variables na yon. Pangalawa, objectives. Ang isang halimbawa ng objective ay i-maximize mo yung profit. So, objectives are linear function of an optimization's variables. Pag naman sinabing constraints, ito ay linear functions din ng optimization's variables and are used to restrict the values an optimization can return for a variable. Ang example ng constraints ay specified ratio of budget allocation or total number of items a factory can produce. Now let's discuss optimization. Optimization is a way of life. So meron tayong finite or limited resources and time, and we want to make the most of them. So, from using your time productively to solving supply chain problems for your company, everything uses optimization. So, this topic is very interesting and relevant in terms of data science. So, let's say for example, the problem is sharing a bar of chocolate between siblings. So you want to make sure that you optimize your limited resources. In this case, it's the bar of chocolate. So, in sharing the bar of chocolate, we don't solve it mathematically, right? Pero paano kung ang problem mo, kasi nga simple lang yung problema. Pero paano kung ang problem mo is you want to devise your inventory or you want to make or strategize your warehousing. So these are some problems that are very complex, and optimization is the key or a specific process that we want to apply for us to be able to maximize our resources and our time. So what linear programming really is? Linear programming, or LP, is a simple technique where we depict complex relationships through linear functions and then find the optimum points. Okay, so let's take a look at this graph. This graph has x-axis and y-axis and several lines. So these lines is what we call linear functions. So these linear functions, it could be objectives and constraints displayed in a graph. So the variables, kung mapapansin mo, meron tayo dyang variables na x and y na kung saan yung values nila ay hindi pa known. So this chart, once na yung mga linear functions natin ay nag-meet or nag-intersect, meron tayong tinatawag na feasible region. Okay, so this feasible region sa isang linear program or optimization is achieved through plotting your objective and constraints. So every corner point of this feasible region, so if this is your feasible region, every corner point here will be your maximal or minimal feasible value for your objective. So lahat ng corner points dyan natin, ayan yung tinatawag na maaaring maximal or minimal feasible value for the objective. Now let's discuss about formulating a problem. Okay, so let's all watch this video, Formulation 1 by Don't Memorize.
Linear programming is a technique which helps us to find the optimum solution for a given problem. An optimum solution is that solution which is the best possible outcome of a given problem. Before we discuss how a linear programming technique is used to solve problems, let's understand what kind of problems can be solved using this technique. Did you know that this technique is widely used in different industries? This list includes different types of linear programming problems. Let's now focus on the structure and the formulation of a linear programming problem. We first need to understand the given problem and then identify the basic elements to convert it into a linear programming problem. This process is called as the formulation of a linear programming problem. Understand it well. We first need to convert a given problem into a linear programming problem and then solve it. So there are two aspects here, the formulation part and then the solution part. Let's begin with the formulation of linear programming problems. Go through this example. We have to find the maximum profit the company can earn with a constraint. The constraint here is the production budget. But how do we approach this problem now? First, let's try to represent this problem in a tabular form. Can you give it a try? Here it is. Go through it well. Note that we have to convert this problem into a linear programming problem. And how do we do that? By writing the given problem in the form of mathematical expressions. Like in this case, the company wants to sell some number of products A and B. As we don't know the exact quantity, let's assume the number of units of product A to be X and the number of units of product B to be Y. Now, can you tell me the total cost to manufacture these many units of A and B respectively? Yes, it will be 200 times X and 150 times Y. We're just multiplying the quantity with the price. Next, let's look at the constraint. It says the production budget is $50,000. That means the cost to be incurred should not exceed $50,000. It can be less than or equal to $50,000. Can you write this constraint in the form of a mathematical expression? Here's the answer. This expression represents the budget constraint of the problem. The total cost should not be more than $50,000. Now let's express the total demand of the two products in a similar manner. Give it a try. The combined monthly demand of the two products will not exceed 500 units. Therefore, we use the less than or equal to sign to write this expression. And which constraint does this expression represent? Yes, it represents the demand constraint of the given problem. This means if the company produces more than 500 units of products A and B in all, it might not be able to sell them. Are there any other constraints in the problem? Not really. So let's look at the profit element of the two products. Can you tell me the objective of the company in this case? The company would like to sell its products A and B in such a mix that it yields maximum profit in a month. In simple words, the company would try to maximize the profit which it can yield by selling A and B. Now let Z denote the total profit for the month. Can you write the total profit in the form of mathematical expression? The total profit Z can be written as this. It's the product of the quantity and the profit per unit. With this, we will write the objective function of this problem. The objective function in a linear programming problem is a mathematical expression of the ultimate goal. So, we have the two constraints here, a budget constraint and a demand constraint. This is how the whole problem looks in terms of mathematical expressions. This is the objective function, and these are the two constraints. There's just one thing we need to know here, and for that, I want you to answer a question. Can the number of units produced by a company be negative? You're right, it can never be negative. So we need to add the non-negative constraints. It can be written mathematically like this. It's very important to write the non-negative constraints in the formulation of a linear programming problem. Did you notice what we did? The entire problem of so many words is reduced to the simple format using mathematical language. As the problem is formulated in the linear form, it's called as linear programming.
Okay, let's discuss a sample problem. A sample problem about chocolates. Consider a chocolate manufacturing company that produces only two types of chocolate, A and B. Both the chocolates require milk and choco components only. To manufacture each unit of A and B, the following quantities are required. Each unit of A requires 1 unit of milk and 3 units of choco. Each unit of B requires 1 unit of milk and 2 units of choco. So, pwede nating sabihin na itong Unit A na chocolate na pinuproduce ng kumpanya na yon ay maaring dark chocolate, while yung Unit B, ang napoproduce nila ay milk chocolate. So, halimbawa, ito yung ating Unit A. Ang component daw nito or yung ingredient daw nito ay isang unit ng milk at 3 unit ng choco. While itong Unit B na napoproduce ng kumpanya ay ang kailangan niyang raw material ay 1 unit of milk and then 2 units of choco. Ngayon, yung sa kitchen daw ng kumpanya, merong natitira na 5 units ng milk at 12 units ng choco. So, yung raw materials natin ay 5 milk at 12 na choco na units. So, kada daw nabebenta na Unit A at Unit B, for Unit A, ang profit daw ng kumpanya ay 6 pesos, while for Unit B, ang profit ng kumpanya is 5 pesos. Now, here is the question that we need to answer. The company wishes to maximize its profit. How many units of A and B should it produce, respectively? Kung gusto daw ng kumpanya na i-maximize yung kanyang profit, ilang daw A at ilang B yung ipoproduce niya given that this is your limited resources. So, ang tawag doon is optimization problem. So, we need optimization solution. So, kailangan natin itong isolve using linear programming. At ang solution na ating gagawin mamaya ay graphical solution. But first, let's try to analyze the problem or the scenario. So, sabi doon kanina, ang raw materials na meron daw sa kitchen ay 5 units ng milk at 12 units ng choco. Ang Unit A na chocolate na napoproduce nila, ang kailangang ingredient ay 1 unit ng milk at 3 unit ng choco. Kada napoproduce na chocolate A, may profit na 6 na piso. Samantalang, yung unit ng B na chocolate na napoproduce ng company, ay ang kailangan niyang raw material ay 1 unit ng milk at 2 units ng choco, na kung saan ang profit na napoproduce ay 5 piso. Given these raw materials, alin daw yung combination na ipoproduce dapat ng kumpanya para mas malaki ang kanilang maging profit? So, it could be combinations of A and B, madaming A, walang B, konting A, madaming B, walang A at madaming B. So, yun yung mga pwedeng maging scenario. At iba-iba sila, ibang combination, iba ng total number of total profit. So, ito yung mga scenarios na pwedeng mangyari. Pwede kang mag-produce ng 4 na units ng A at 0 units ng B, na kung saan ang total raw materials na iyong magagamit ay 4 na milk kasi 4 na chocolates, tig-1 at tig-3 chocolates or units ng choco. So, all in all, ilan na nagamit natin na raw materials? 4 na units ng milk at 12 na units ng choco. So, kapag ito ay pinag-add mo at ito din, ito yung total number of raw materials. Kasi limited yung ating raw materials, kailangan ay mas mababa or pantay doon sa total number of raw materials. We cannot add any further. Why? Because we have limited raw materials. So, if you want to produce all Unit A and then none of Unit B, then you can only produce 4. So, this is our first scenario. 4 units of A and 0 units of B. To compute the profit, then we need to equate Z with the value of 6x plus 5y because every unit of x, meron tayong 6 pesos na profit. And every unit of y, meron tayong profit na 5 pesos. So, 6 times 4 plus 5 times 0, that is 24 pesos. So, if ito yung ating gagawin, scenario 1, then ang ating profit ay 24 pesos only. Meron pa tayong iba pang scenario. Pwede naman na 3A. So, kung 3A yung ating gagawin, ang B na pwede natin gawin ay isa lamang. Kasi, kapag dinagdagan natin ng isa pang B, labis na dun sa limit ng ating choco. Okay? So, we have here, kung tatlong choco, kada isang unit A ay isang milk, tatlong choco, sa tatlong beses niyan, at isang B na kung saan ay isa lang milk at dalawang choco yung raw material. So, kapag in-add mo yan lahat, ang raw materials na nagamit mo ay 4 na milk at 11 na choco. So, for our second scenario, meron tayong tatlong A at isang B. If we will compute the profit, 6 times 3 plus 5 times 1 is equivalent to 23 pesos. So, ang favorable pa din na i-produce natin ay itong naunang scenario. Pero hindi pa dyan nagtatapos kasi meron pa tayong ibang scenarios na pwedeng gawin. And that is, dalawang A at tatlong B. So, kapag dalawang A at tatlong B, ang total raw materials na nagamit mo dito ay 5 milk at 12 na choco. So, 5 na milk at 12 na choco. 3, 3, 2, 2, and 2. So, overall, that's 12 choco. So, we have dalawang A, tatlong B. Ang profit niyan ay 6 times 2 plus 5 times 3 is equal to 27 pesos, na mas malaki kaysa dun sa nauna. Yung nauna ay 25 pesos lamang kung ito yung gagawin mo, at ito naman ay 23 pesos kung ito yung gagawin mo. Samantalang kung ito yung combination na gagawin mo, may profit ka na 27 pesos. So, let's proceed to the fourth scenario. In our fourth scenario, ang pwede naman natin gawin ay pwede naman na isa lamang na A at 4 na B. So, the total number of raw materials that we used are 4 milk and 11 choco. So, kung isang A at 4 na B, ang profit mo ay 6 times 1 plus 5 times 4. That is equivalent to 26 pesos. So, mas mataas pa rin kung dalawang A at tatlong B. Right? So, meron pang panglimang scenario. And that is, walang A at 5 B. The total number of raw materials na ginamit natin ay 5 milk at 10 choco. So, mas hindi siya lumabas dun sa ating mga limitations. So, this is still valid. If you will add another B, labis na. Wala na tayong 6 na milk. 5 lang yung milk natin. So, even if ma-exhaust natin yung 12 choco, wala na tayo for the milk. So, we cannot add any more. So, kung 0 na A at 5 B, ang profit natin ay 25 pesos. So, obviously, kung ito yung gagamitin natin na method, ang ating optimum value for our variables X and Y or A and B is 2 and 3. Ang na-maximize natin yung profit, which is Z, ay 27 pesos. So, that's what linear programming is all about. You can do that using process in linear programming. So, this is the step 1 in that process. First, identify the decision variables. The decision variables is the number of unit A produced, let that be X. Second, the number of unit B produced, let that be our Y. And our profit, let that be Z. Our second step is to write the objective function. Ano yung gusto mong mangyari? Ano yung goal ng anong goal sa ating problem? Ang goal is to maximize the profit, and the profit can be solved by this equation. 6 times X, kasi kada isang value ng X, which is our unit A produced, meron tayong 6 pesos na profit, na kailangan mong idagdag dun sa profit mo naman, dun sa unit B, na kung saan 5 pesos yung profit mo for every unit B produced. So, the word maximize should be added because we want to maximize the profit. So, maximize Z is equal to 6X plus 5Y. All of these equations and all of these variables came from our word problem. So, here's our third step. The third step is to write the constraints. The constraints would be the availability of the materials. For unit A, you need 1 unit of milk and 3 units of choco, while for B, you need 1 unit of milk and 2 units of choco, but you cannot exceed the limitations of having 5 milk and 12 choco. Therefore, your first constraint is that when you add X plus Y, it need not to exceed 5. Kaya siya X plus Y kasi 1 unit ng milk at 1 unit ng choco, dapat siya ay less than or equal to 5 lamang. While meron tayong second constraint, and that is for this scenario. So, kailangan natin for every unit of A, tatlo for unit A at dalawa for unit B. So, the second constraint is 3x plus 2y should be less than or equal to 12. So, that is our second constraint. For the last step, kailangan mong isulat yung non-negativity restrictions. Pag naman sinabing non-negativity restrictions, may mga values dyan, which is our variables, ay kailangan ay positive values. Hindi siya pwedeng negative. So, x and y need to be greater than or equal to 0. Okay, so mamaya natin i-discuss yung solution to this linear programming problem. But I want to discuss with all of you the common terminologies na ginagamit sa linear programming. So, na-discuss na natin to kanina, but let us discuss this further. Pag sinabing decision variables, ito yung variables that will decide your output. They represent your ultimate solution. So, para ma-solve mo isang problema, kailangan mo munang i-identify yung inyong decision variables. Doon sa example natin kanina, ito yung total number of units for A and B denoted by X and Y respectively. They are the decision variables for that particular linear programming problem. Second term, objective function. Objective function is the objective of making decisions. So, in our example previously, the company wishes to increase the total profit represented by what variable? Z. So, profit is the objective function, and particularly, we want to maximize our profit. So, you have to devise your objective function. Your objective function in our example a while ago is Z, maximize Z is equal to 6x plus 5y because that determines your profit for each unit. Now, the constraints. The constraints are the restrictions or limitations on the decision variables. So, usually, ito yung nagle-limit ng value ng ating decision variables. Yung sa example natin kanina, ang limit is the availability of resources ng milk at choco. Kasi meron lang tayong 5 milk at 12 na choco. So, ito yung magsisilbi yung constraints ng ating linear programming problem. Ang non-negativity restriction naman, yung mga decision variables natin, ay kailangan ito ay hindi negative values, so you have to put this also. Wherein yung x at yung y should be greater than or equal to 0. That's how you write non-negativity restriction. So, the process, again, to formulate linear programming problem is first, whenever you see a word problem, i-identify mo muna yung decision variables. Pangalawa, isulat mo yung objective function, maximize or minimize. And then, isulat mo kung ano yung formula. Pangatlo, mention the constraints. Ano yung mga limitations? And then, write it down also. And then, pang-apat, explicitly state the non-negativity restriction. This is the last step. So, sa linear programming, yung ating decision variables, yung ating objective function, at constraints natin ay kailangan sila ay maging linear functions. So, makikita natin yon sa ating graphical method. How to solve linear programs by graphical method. Here's how you do it. So, una, sundin mo muna yung mga process na nabanggit ko kanina. So, isulat mo yung variable, i-determine mo yung objective function, isulat mo yung constraints, at yung non-negativity restriction, and then you need a graph like this. So after you have written all of the necessary values, then you have to look at your constraints. You have two constraints. You have to replace x and y with values that satisfies the equation. Okay, so move lang natin, yan. So you have to replace x and y, nitong constraints na to, ng mga values na magsasatisfy dun sa equation. Ang una mong gagawin dyan, gagawin mo muna, what if 0 yung value ng x? Ano yung magiging value ng y? So in this case, huwag nyo munang pansinin yung ating itong mga symbol na to, which is less than symbol. Kapag 0 yung ating x, yung y should be 5 because ito yung gusto nating makuha na value na i-return nitong ating equation. So, yung x value natin ay 0, therefore our y value is 5. So, now we get our first coordinate which is 0 and 5 for this constraint linear function. Now, ang sunod mo namang tingnan ay paano kung yung y natin ay 0, ano yung magiging value ng x? So kung y natin ay 0, then our x should be 5 para makuha natin yung result na 5. So our x value is 5 and our value is 0. Now we get our second coordinate, which is 5 and 0. So if you will plot this constraint linear function using these two coordinates, then you will get a line. So ito yung ating point na 0, yung x, and then 5. 1, 2, 3, 4, 5. 0, 5, the point is located here. While for our second point, 5, 0, so x muna, sa x-axis ka muna, tapos ay pataas, y. 1, 2, 3, 4, 5, 0. So, andito yung ating second point. So, you have to draw a line there. So, for the linear equation, for our constraint linear equation, x plus y is less than or equal to 5, ito yung kanyang rin-represent na line. Now, let's proceed to our second constraint. Our second constraint is 3x plus 2y. Okay, so andito siya. Ito yung ating second constraint. 3x plus 2y is less than or equal to 12. So again, you have to replace x and y with values that satisfies the equation. So gagawin mo lang ulit yung ginawa mo dito sa first constraint. So una, kapag yung x ay 0, ano dapat yung value ng y? Since meron ka ditong 2 times, you have to get a value na kung saan ito ay 0 at ang magiging sagot ay 12 given that you have 2 here. So the value of y should be 6 because 6 times 2 is equivalent to 12. Because you have 0 here, wala ka nang idadagdag pa. So our x value, if our x value is 0, then our y value is 6. So you have the third coordinate. Now, yun namang y yung gawin nating 0. Kung yung y ay 0, ano dapat yung value ng x? So dapat ito ay 4 dahil meron ka ditong i-multiply mo pa yung value, whatever value here, should be multiplied by 3. So, 3 times 4 is 12, plus 0 is equivalent to 12. Again, i-disregard nyo muna yung less than sign. Okay, so, if our x is 4, then our y is 0. Now, we have our fourth coordinate, which is 4, 0. So, i-plot natin yung 0, 6, tsaka yung 4, 0 for our constraint linear function na 3x plus 2y is less than or equal to 12. So here is our 0, 6, and here is our 4, 0. So you have to draw a line to plot our second constraint linear function, which is 3x plus 2y is less than or equal to 12. So here is our second linear function. Now, kung saan sila nag-meet, ang tawag doon ay corner points. At yung area na yon is what we call feasible region. Okay, so wherever they met, since maximize yung ating gustong mangyari, dapat siya ay pababa here. So, going to the left and down. So here is our feasible region, and where the points where they meet is our optimal, maximal, or minimal value. In this case, yung maximal value natin, optimal value, ay isa sa mga points na to. Yung 0, 5, yung 2, 3, at yung 4, 0. Kailangan natin silang i-plot sa ating objective function para malaman natin alin dun sa combination na yun, dun sa coordinates na yun, ang ating optimal value. So, since we now have our corner points, we can now replace the values of those coordinates to our objective function, replacing x and y with that particular coordinate. So we have here 3 coordinates, 0, 5, 2, 3, and 4, 0. So you just have to replace x and y to our objective function, and then you will get our particular profit for that combination. So kapag 0 daw na A at 5 B, ang ating profit ay 25. Kapag 2 A at 3 B, ang ating profit ay 27. Kapag 4 na A at 0 na B, ang ating profit is 24. So since maximize Z yung hinahanap natin, kukunin mo yung pinakang mataas. So in this case, it's 27. So this is our optimal value, 2 and 3, for the profit of 27 pesos. Okay, so ganito i-solve yung linear programming kapag ang gagamitin mo is graphical solution at hindi yung kanina na in-line up natin lahat ng scenarios. So this is our optimal value since we have replaced the values on our objective function. So to further discuss about linear programming graphical solutions, let us all watch this video.
So far, we've discussed the meaning, applications, and the formulation of linear programming problems. We will now discuss how a linear programming problem is solved. Before we begin, can you tell me what an optimal solution is? The maximum or the minimum value of an objective function for the given problem is the optimal solution. But the question is, how do we solve a linear programming problem? Well, there are different ways to solve these problems. The problems having two variables can be solved graphically. Like in this example, there were only two decision variables, x and y. While in this example, we had three decision variables and hence we can't solve it graphically. In such cases, the problems are solved using the simplex method. For now, we will be discussing the problems based on the graphical solutions. To solve a linear inequality with two variables on a graph, we will use a coordinate plane. We know that there are 4 quadrants in a coordinate plane. As the decision variables in a linear programming problem should satisfy the non-negativity constraint, the values of x and y should not be less than 0. It means they will lie in the first quadrant only. Therefore, to solve these problems on a graph, we need to use only this quadrant. For better understanding, let's solve this linear programming problem graphically. In this problem, we need to find the maximum profit, which is denoted by the objective function z is equal to 50x plus 18y. So let us find the values of x and y which satisfy this linear inequalities. As the solution needs to be found using a graph, let's represent these inequalities on a coordinate plane. How do we graph inequalities? We will first write the corresponding equations for these inequalities. Can you write them here? That's right. These are the corresponding equations. Next, we need to graph the lines of these equations. And we can do that by finding the coordinates of x and y intercepts. Let me help you with the x and y intercepts of the first equation. For the x-intercept, we substitute y equal to 0. We get the value of x as 50. So the coordinates of the x-intercept are 50, 0. And to find the coordinates of the y-intercept, we substitute x as 0. That gives us the value of y as 100. The coordinates of the y-intercept are 0, 100. Similarly, we get the x and the y-intercepts of the second equation. With these points, let's draw the two lines representing these two equations on a graph. Let's mark the 4 points first. With this, the first line can be drawn like this. It represents the equation 2x plus y is equal to 100. Likewise, let's draw the second line representing this equation. Give it a try. Here's the line representing the equation x plus y is equal to 80. So how will this graphical presentation help us find the optimal solution? We will first mark the feasible region of this graph. Do you know what a feasible region is? It's the common region determined by all constraints of a linear programming problem. Each point of a feasible region satisfies the linear inequalities of the problem. So let's mark the feasible region for this problem. If we consider only these two linear constraints, all the points of this quadrant will satisfy the given inequalities. And hence this entire quadrant can be the feasible region. However, if we consider these two constraints as well, the feasible region will get restricted to the region O, A, B, and C. As you can see, the two lines intersect at point B 20, 60. The region within these 4 corner points is the feasible region of this problem, as each and every point of this region will satisfy the linear constraints of the problem. For instance, let's take the point 30, 40. If we substitute these values for x and y respectively in the linear inequality x plus y is less than equal to 80, we will see that the point satisfies the linear inequality. In this way, every point within and on the boundary of the feasible region can be the feasible solution for the given problem. It means the points on and within the region satisfy the linear constraints. Then how will we find the optimal solution? Since there are many possible solutions for this problem, we will use the corner point method to find the maximum profit. Now, what's a corner point method? In this method, the solution of a linear programming problem lies on the corner point of a feasible region. The coordinates of the corner points are substituted for the values of x and y in the objective function. In this example, points O, A, B, and C are the corner points of the feasible region. We will evaluate the objective function by substituting these points as values of x and y one by one. First, let's find the value of z at point O. The coordinates of point O are 0, 0. 50 times 0 plus 18 times 0 gives us 0. Likewise, can you fill in these values of z? For the second point, we get the value of z as 1440. 2080 for the third, and 2500 for the fourth point. So we have all the four values of z at the corner points of the feasible region. Since our objective is to maximize z, the optimal solution lies at point C 50, 0 because the value of z is maximum at point C. This is how we solve a linear programming problem graphically.
For your assessment activities, you have to do your engagement activity 3.2 and your task performance 3.2. So please open your Google Classroom and check if the assessment activities are already available. If not, it will be available on your day 3 schedule in ITEP 203. So that's the end of our discussion. Thank you so much for listening.